Hey guys, this is video 9-4, and in this video we're going to be talking about how to convert from moles to grams and vice versa from grams to moles. So this is going to build on the idea that we talked about in video 9-3, which is the idea that when you're looking at the periodic table, and here we just have a mock-up of a box from the periodic table, any element that you look at in the periodic table, so X could be any element, you're going to have the atomic number and you're going to have the atomic mass, right? And the way the periodic table is set up for this particular element, okay, if we have 1 mole of it, then mass-wise it will be equal to this number, which is the atomic mass, in grams. Okay, so in other words, 1 mole of X is equal to blah 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 grams. Okay, so that means if I have 1 mole of carbon, how many grams of carbon do I have? Well, let's go to the periodic table, right? So if we go to the periodic table and we find carbon, carbon is right here. Okay, it is a mass of 12.01, which means that 1 mole of carbon will have a mass of 12 grams. That 12.01, which is the number that would be here, right, for carbon. Okay, remember we round that off to the nearest whole value, so in this case 1 mole of carbon would have a mass of 12 grams. Okay, so if we had 2 moles of carbon, meaning basically we have twice as much, right, we'd simply take the mass of 1 mole of carbon and we just double it. So 12 grams times 2, which means we'd have 24 grams of carbon. Cool? Cool. However, since we're in chemistry class, we need to write everything out so we don't make any mistakes. That means we need to get back to this. We need to get back to writing out our dimensional analysis problems, which means you take the given value, which in the previous problems, 1 mole and 2 moles, those would be our given values, right? And then conversion-wise, for this value, for the above and below the line, this is where your molar mass is going to be plugged in. Molar mass we talked about in the last video, 9-3. Molar mass, remember the units are always grams per mole. So when you take the value from the periodic table like this, carbon, for instance, its molar mass is equal to 12 grams per mole. Alright, so let's look at an example here. If you have 3 moles of water, how many grams do you have? Okay, well, let's see. Our given is 3 moles, right? So we know that we have 3 moles of H2O, right? Then we do our line, so dot and line, okay? Now we need some numbers here, okay? Well, we know that we have moles and we want to get to grams, right? That's what they want. So in dimensional analysis, we always want the units to cancel out. We want to get rid of the units that we have, and we want to end up with the units that we want. So that means we're going to have to get rid of the units of moles here. So that tells us right off the bat, moles are going to have to go on the bottom. Okay? And we want to get to grams. So can we get straight from grams to moles? Well, yeah. All we need is the molar mass. So how do we figure out the molar mass of water? Well, we add up the mass of each atom in the water molecule, right? So hydrogen, if we go to the periodic table, has a molar mass of 1 gram per mole. Oxygen, on the other hand, has a molar mass of 16 grams per mole. So if we add those all together, keeping in mind that water has 2 hydrogens, right? So that means 1 plus 1 for 2 hydrogens. And then we add in the mass of that oxygen, which is 16, that tells us that water has a molar mass of 18 grams per mole. Okay? Another way we could write this, if it helps you, is it's 18 grams over 1 mole, meaning 1 mole of water is equal to 18 grams. Okay? So, you could say, oh, I can do this in my head now because I know I have 3 moles of water, so if each mole is 18 grams, I could just multiply it out and get the right answer. But again, dimensional analysis is going to be our friend in the future, so we need to practice it with problems that are easy so that when we get to those tougher problems, it's not going to throw us off. Okay, we're not going to make silly mistakes. So, again, moles on top means that we need to put moles on the bottom over here. Now we're going to use this conversion factor we just created, this molar mass, to convert. So we've already plugged in the moles. Notice the number next to moles is 1, so I'm going to put a 1 here. Okay, I look at the other side of the line, it's 18 grams. So I simply plug in that 18 grams right here. Notice when I do that, the moles on top and the moles on bottom are going to cancel out. Okay, I just simply do my math problem now. So 3 times 18, okay, that's going to give me 54. So that's 54. And then when I want my units, okay, notice moles disappeared. I'm left with grams. And don't forget your substance. We need to know what we're measuring. So it's 54 grams of water. So 3 moles of water, you have 54 grams of water. Okay, now let's look at this with a couple more, I guess, complicated problems. So let's move up here. So the first one that I want to look at is if we have 2 moles of sodium chloride. Okay, so remember, dimensional analysis is key here. So we always write down our given. In this case, our given value is 2. Okay, let's give it some units. So in this case, moles. Okay, and don't forget the substance. Eventually, we're going to be dealing with multiple substances, and so you want to get in the practice of writing the substance next to the measurement, so that you know this is 2 moles of sodium chloride. Now we do our dot line. Okay, and right off the bat, especially if I know that I'm going from grams to mole, I can go straight from moles to grams or grams to mole. That means I know I'm going to get rid of these units, right? So if moles are on top, that means moles need to be on the bottom. Okay. Now, to get from moles to grams, I need molar mass. So let's get that. That means that we need to find the mass of sodium, and we need to find the mass of chlorine. Okay. Now chlorine I know because that's the one that we have to remember. Chlorine is the only element that we don't round off to a whole value, so its value is 35.5. If I don't remember, I can go to the periodic table, I can look up chlorine, which is over here. It's 35.45, it's right in the middle, so we round that off to 35.5. Sodium, on the other hand, is over here. We're going to round that off to a whole value, it's 22.99, so we'll round that off to 23. Okay, so going back, we need the molar mass of sodium chloride, so if we add these two together, and notice the subscripts are 1 and 1, so it means simply add 1 sodium to 1 chlorine. 23 plus 35.5 is going to give me 58.5, right? And this is the molar mass, so I give it units of grams per mole. So the mole I've already plugged in down here. Now there is a unit of 1, or a number of 1, right next to the mole. We just ignore it. We ignore it. So what that means is we can put a 1 right here. Okay, the 58.5 grams is going to go on top. Okay, notice our moles are going to cancel out. We're left with 2 times 58.5, which is going to give me, was that 117, sorry, 117, and then units are grams. And don't forget the substance, sodium chloride. Easy peasy, right? Well, then let's do that for hydrogen fluorine, only now we're going to go in reverse. Sorry, hydrogen fluoride. We have grams, and we're going to go 2 moles. So first thing we do is we always write down our given. So in this case, it's 60 grams of hydrogen fluoride. Okay. Then we do dot line. Okay. Now, as I said, when you're going from grams to moles or moles to grams, you can already start by plugging in your first unit. So grams, well, we're going to get rid of grams because we want to go to moles. Okay, you can always have grams and moles on opposite sides of each other. Okay, you can always go from grams to moles or moles to grams. Basically what I'm saying. Now we need to know the numbers that we plug in here. So to do that, we need, as I said up here, we need the molar mass. Only this time we need the molar mass of hydrogen fluoride. So hydrogen, we know, has a mass of 1. Okay, fluorine, on the other hand, we need to look up real quick. So we go to the periodic table, we find fluorine. Okay, he's right here. It's 18.998, so we're going to round that off to 19. Okay. Now notice that again we have 1 hydrogen and 1 fluorine, so we can simply just add these two together. 1 plus 19 is going to give us 20. What are the units? Well, we want molar mass, so it's going to be grams per mole. Right? Don't forget, there's really a 1 right here. We just don't write it. So it's 20 grams per 1 mole. So that means when we plug these in, right, the 1 goes next to the moles, and then the grams, you plug in the value that you came up with by adding them together. So in this case, it's 20. So notice our grams will cancel out, grams on top, grams on bottom, they disappear. 60 divided by 20 gives us 3. The units are moles, and then don't forget your substance, HF, or hydrogen fluoride. Okay, now let's do one more just for kicks. So I'm going to clear this up so we can see a little better. So now they want how many moles of calcium hydroxide are in 37 grams. Again, we're going kind of in reverse. We are going from grams to moles, okay? But it all starts off the same. So we always write the given first. So whatever number they gave you, you write that down first. So 37 grams, and then we're going to write the substance, calcium hydroxide. Okay, now next step is our dot and our line. And remember, going from grams to moles or moles to grams, you can automatically fill in the units. We have grams, so we want to get rid of those, and we want moles, so we put moles on top. Okay. Now, to get from grams to moles or moles to grams, we always have to figure out the molar mass. Okay, that's the key in this unit, is figuring out that molar mass. So we have calcium and oxygen and hydrogen, so we need those values so we can add them all up together to get the molar mass of calcium hydroxide. Calcium we need to look up. Oxygen, that one we deal with so often that I have it memorized, 16. Hydrogen is 1. Okay, so let's quickly take a look at calcium. Calcium on the periodic table has a mass of 40.078. That means we'll just round that off to 40. Okay, so if we add these all up together, there's 1 calcium, so that's 40 plus, okay, we have a subscript of 1 here for the oxygen, but there's 2 outside, so we multiply that in. So that's 40 plus 16 twice because there's 2 oxygens. And then hydrogen has a subscript of 1, but again we have to multiply that 2 in, which means we have 2 times 1 or 2 hydrogens. So we add 1 twice because we have 2 hydrogens each with a mass of 1. So that's 40 plus 16, which gives me 56, plus another 16, which is going to give me 72, plus 2 is going to give me 74. Okay, so that's 74. Again, it's the molar mass, so we give it units of grams per mole. Okay, the mole is going to get a 1. The grams, we'll plug in that 74. Okay, so we're left with the grams canceling out, because grams on top, grams on bottom, 37 or 74. So initially you might say, oh, this is tough, I don't know what he wants me to do math-wise here. Okay, if you're having trouble, just multiply through. So 37 times 1 is 37. Divide that by 74. The units are moles. Okay, if you sit here and stare at it long enough, what I'm hoping you see is that 37 goes into 74 twice, which means we can reduce this. So we can cancel out the 37, turn that to a 1, cancel out the 74, turn that to a 2. You're left with 1 over 2, which is the same thing as 0.5 moles. Don't forget your substance. Substance is calcium, OH2, so calcium hydroxide. Alright, so that's the end of this video. Make sure that you've completed your notes, make sure you answer your WIS questions, and make sure you create a hot question for this video. We'll see you tomorrow.